We are back here at ISO Math, and we're still talking about transformations of trigonometric functions, and we are going to transform a cosine function in this video. So here's my problem. Sketch one period of the graph of g of t equals 1/2 cosine 1/2 t plus 1/2 minus 2. Okay, so as last time, first thing I'm going to do is rewrite the function. G of t equals 1/2 cosine of, pull that 1/2 out of the t and the 1/2 over there, so I have t plus 1. We have minus 2 there. So let's get all of our things that we want to get. Let's get the amplitude. Amplitude is going to be determined by the coefficient of the cosine there, which is 1/2. Okay, so next I want to get my period. Note that in here we have that 1/2. That thing's going to make the cosine run around the circle slower. Okay, it's going to be half as fast as 2 pi. And so officially how we get it is 2 pi over 1/2, which equals 4 pi. Okay, so it's going to take this thing 4 pi seconds. So let's think of that t as seconds. So I'm going to take it 4 pi seconds to run around the unit circle. And then I like to do my magic number. A magic number, I take the 4 pi, I always take the period and divide by 4. That equals pi. Okay, that's going to tell me that it takes pi seconds to get around each quadrant. Takes pi seconds to get around. Okay, takes pi seconds to get around each quadrant, each quarter of the unit circle. Okay, it's going to take pi seconds to get around there. It makes life easy when it comes to graphing these transformations. Phase shift is next. Remember, that's my horizontal shift. Okay, I look inside the cosine and ask myself, how do I make that 0? Well, I'll make that 0 by making t a -1. That means it's going to move my cosine function back on the horizontal axis a length of -1. And last is my vertical shift. Vertical shift equals vertical shift is going to be that -2 there, so it's going to take the graph of the cosine and shift it down -2. Okay, now the fact that this phase shift was a -1 makes me have to look at my graph. I mean, it's all the same, but I have to label my axes with integers. Well, you don't have to, but I prefer to. But it's still the same graph no matter how you label your axes. So let's jump to, I have a predetermined page here where here in red I've graphed the original cosine function. And because I graphed it with, if you notice here that I'm using integers on my t-axis, I'll use these numbers here. So that is f of pi over 2. When I plug pi over 2 into cosine, I get 0. So that 1.57 is right. So that's about, oops, I should have kept that red. It's about 1.57 there. And down here, so at pi is 1, 2, about 3.14 right in there. And 3 pi over 2 is about 4.71. So 1, 2, 3, 4, 1, 2, 3, 4.71. That's going to be where the cosine of 3 pi over 2 is 0. And then at 2 pi, which is about 6.28, we see here is 5, 6, a little bit past the 6 there, 6.28. That's when we're back to the cosine of 2 pi. The cosine of 2 pi is 1. Okay? So let's do this, and note again that now that I have all this information, I don't even look back at my original function. I just take this, look at the original cosine, and I can go. Alright? And I'm going to need, the first thing I want to look at is my vertical shift of -2. So right here, vertical shift of -2. That tells me that everything is going to be, that my new t-axis here is down here at -2. Okay? Next thing I'm going to look at is the phase shift. That tells me that it moves the cosine of 0, takes that point there and backs it up to there. Okay? So that's going to help me get my starting point. So that's where I'm going to have, so when I plug a -1 in there, I get a cosine value, cosine of 0, which gives me a 1. But I know that my amplitude is 1/2, so I don't go up to 1, I just go up to 1/2. Okay? So think about it here. This moved it, the phase shift there moved it back to -1, so I start back at -1, but I don't start up here at 1 above my horizontal axis. I start at the 1/2, okay? Because of the amplitude. So I start at 1/2. And let me go in, let's go in yellow. Okay? So we start right there. And now that I know that, I just go. Okay? I know that my magic number is 3.14. So I go over 3.14, and I know that at that point I have gone the first quarter of my circle and that my cosine value is 0. So I go over 3.14, and that's, so I'm at -1 here, and I add pi, and that puts me over at 2.14. So 2.14 is going to give me somewhere about in there. Again, we're just sketching the graph. Okay, so now from 2.14, I add another magic number of pi. That's going to give me my, when I'm back at where my cosine value is -1, so at 5.28, so somewhere around in here, but it's not -1, it's -1/2 because of my amplitude of -1/2. Okay, and now from 5.28, I add another pi, which gives me about 8.42, and that's when I went through the third quadrant of my unit circle, and so my cosine value is 0 again. So at 8.42, 5, 6, 7, 8, 8.42, let's say right in there. Okay, and then I complete the last quadrant of my unit circle, the last quarter of it, by adding another pi, and that puts me at about 11.56. 10, 11, 11.56, and that's, again, the cosine value is going to be 1/2 there. And now that gives me one trip around the unit circle. That is one period of the cosine function that we had to draw. I had to sketch, I should say. Okay? Hope that helps you out. Again, you have to do a couple of these to get this down and try to understand why things are happening, and try to do it less by just memorization of an algorithm, but try to understand what is actually going on with these cosine, with the cosine function and the sine function when you graph them. It will help you out in the long run, I assure you. Again, for those of you who are moving in the STEM directions, who are going to be doing a lot of science, a lot of math, engineering, this will be very beneficial to you. We'll make one more video, and the next one I will be given a graph, and by looking at that graph we will figure out a function that describes the graph. Okay? See you in the next video.